Hi everybody, welcome back. Today we're going to do a review about trends in graph and also the rate of change. The last one is going to be linear model because our test is tomorrow. So anyways, we're going to start. As you know, a graph is a visual representation of the relation between two quantities. It shows how one quantity changes with respect to the other quantity. So as we describe the relationship showing the graphs, as Jack's babysitting earnings, as the number of hours Jack babysits increases, the earning increases by a constant amount. So for the amount of compound interest investment, it's not a linear graph, so it's a different relation, just increases. It's not going to be a constant. Over time, the amount of compound interest investment increases slowly at first and then increases very fast. With the temperature of cooling cup of coffee, over the time, the coffee temperature is decreasing rapidly at first and then more slowly until it stops at a constant temperature. For the graph that said fertilizing a field, I would say as the fertilizer use increases, the crop yield increases to a maximum value, and then it decreases at an increasing rate until no crops grew. So the trend, which is the pattern change in the graph, are used to justify decisions and make predictions. So for the trends in three broad groups. The three broad groups, as I mentioned, they are increasing, decreasing, and constant. So let me look at the example of Ontario bird from 1945 to 2005. So from 1945 to 1960, as in an increasing broad group that it grew from 10,000 to 160,000. So from 1960 to 1975, it's a decreasing broad that it dropped from the 160,000 to 122,000 and 220,000, I guess. It's from 1975 to 1980, the constant broad group that is still the same. From 1980 to 1990 is an increasing broad group that it grew slowly and then gradually to 150,000, 150,000 in 1990. From 1990 to 2000, I can see it's a decreasing broad group that is dropped to 130,000, which is a 130,000. From 2000 to 2005, it's increasing that grew slowly to 135,000, which I say 135,000. So let me do the practice. So as we know, the graph is the age 15 and under, approximately 5.4 million. Age 60 to 80, approximately 6.2 million. Age 80 plus, approximately 1.8 million. So the decision that the Canadian government might make in response to the trend in the graph is to increase immigrants, build more schools, and also release big amounts of job options because people might need to work. So it's just the official practice. I did all of them, so I don't have homeworks for that day. So for the sales out dramatically over the last year, which is the I. The sales have fallen steady over the last 2 years. The number 3, just no, because here it's not dramatically. So this one's a dramatically, this one's not. So the sales remain constant. I would say it's the number 2 because it's just a horizontal line. The sales fluctuated over the last year, which is the number 4 because it's just like a wave. So the wind power is becoming a practical source of renewable energy. The graph shows how the power generated by wind turbine changes the wind speed. To describe the general trend in graph, the general trends in the graph are increasing, as you know. Even though it's not constant, it's still increase because as you can see from the graph, is going up. How much power is generated when the wind is 20 meters per second? And we find that it's 5 blocks per 5 meters per second. So at the 20 it's 100 kilowatts. But I wrote kilometers. My bad, guys. So does the power generated double when the wind speed doubles? No, it doesn't, because the power was 2 kilowatt in 5 kilometers, which is 12 kilowatt in 10 meter per second. See this? So I'm making this. So let's move on to the next practice. So for the number 3, a small company makes and sells t-shirts. This graph shows how the cost, sales, and profits vary as the number of t-shirts produced increases. So the relationship between the cost and number of t-shirts produced. The more t-shirts they produce, the more expensive is the cost, I would say. Describe the relationship between the profit and the number of t-shirts produced. I'd say when they produced 500 t-shirts, it grew to 160,000 for profit. When they produce more, they drop the profit. The 2 decisions will be creating discounts or to produce less t-shirts, because they need to cut the birth rate, because the less people born, the less t-shirts they need to make, because if they increase the birth rate, it means things could be mess. The rate of change, it's a rate how quickly at which something's changing. The rate of change indicated by the slope of the graph. So here's how can determine. The dependent variables can be x1, x2. Independent is x. Dependent is y, y1, y2. The average of rate of change, y2 minus y1 equal divided by x2 minus x1, which is the rise over run, which is what we learned last year from Miss Cylka the pig. Calculating the average rate of change between the pair of points. So for the one that's 0 minutes and 4 minutes, the height is 2,000 and 1,400. So I use the 1,400 minus 2,000 divided by 4 minus 0, which is negative 150. So I will say this. So for the rate of change, the distance is required to stop a car depends on the speed at which the car is traveling. Use the table below. We can use to calculate the rate of change. For the 1, I said 0, 2, 4, 6, 8, 10. The speed is 0, 10, 20, 30, 40, 50. So the speed of kilometers, when they minus together, is always a 10. With the reaction distance, it's also 2. So the rise over run is 2 over 10, which is a 0.2. 1 over 5, you can say anything. You have to follow it. So for the speed of change on the right side, the stopping distance is 0.0, 0.5, 2.0, 4.5, 8.0, 12.5, like that. Or for the speed of change is always 10. It's 0.5, 1.5, 0.25, 0.35, 0.45. Actually, the right side can be a decimal. As long as you remember, rise over run, you never go wrong. But anyways, we have to know the graph. 0 is, is that when they say the change or stuff, no. It grows at a constant from 0 to 4 weeks, then the growth rate increases. From the week 4 to 8, the rate then decreases the plant rears. We stop here until the weeks when 16 when plants stop growing. For the rate of summary, rate of change, the table is 0. The graph just a horizontal line. Constant is the same number whenever the rise over run. It can be dramatically. So the change thing is can be different number, so we have to pay attention on what the question asks you about. You know, the practice, I'll talk about a few of them. So for the pace cell, it's constant from 0 to 40 because the rise over run is always 100 over 10, which is the 10. But for this one, it is different number, I feel like. Oh shit, I'm gonna poop. Sorry guys. So for the rate of change for slope, the rise over 1 for 4 of them is 10 to 15. So you have to be very careful on what you ask about. So linear model is supposed to be an easier one because linear, everything just stay the same, but it has more details, more than just a rise over run. Tables, graph, and equations are all examples of mathematical methods. The linear models represent the quantities that increase or decrease by a constant amount over equal intervals. In the table values, the first differences are the same. The graph is a straight line or stuff. Equation of the line can be written in the form y equals to mx plus b, where m is a slope and b is a vertical intercept. Rate of change is constant. So you can see from the examples, I would take the one that's on the right side. So the time hours 0, 5, 10, 15. The run is always 5. The right side, which is the rise, is 0, 40, 80, 120. So the rise over always 40. No, it's going to be the linear the same. The analyzing graph of relationship. In real world graphs of the linear relationships, which have the vertical intercept represent the initial value of the dependent variables. The slopes represent the rate of change. It's a dependent variable with respect to the independent variables. So I use the coffee things as an example. The coefficient of T 0.5 represents the rate of change in the temperature of the coffee with respect to the time. I will use a y equals mx plus b. The constant 20 is the initial temperature of the coffee at the equal. And that T equals to 0 seconds is 20 degrees Celsius. So for the example 3, it's b equals to 500, represent the cost of the banquet hall. For the slope, I'll say 2000 minus 500 divided by 100 minus 0, which is 1500 divided by 100 equals to 15. $15 per person. So, you know, there are so many I have to talk about with you guys, but the last thing we have to know is that we can use linear regression to the model data that appear to be linearly related. A regression line or equation can be used to analyze data and make predictions. Closer the regression line is to the data point, the more reliable the prediction is likely to be. You know, I'll use this one example. The average increase per year time period slope is 10.25 divided by 4 minus 4 equals divided by 2010 minus 1984. It's a 6.25 divided by 26, which is $0.24 per year, like this. You know, it's actually easier than any other models. But anyways, good luck on the test for tomorrow. Remember, we have to do a very good job in the math test to prove Miss Cylka is a pig.